Welcome to this deep dive. Just take a moment, look around you. That screen you're looking at, maybe a smart thermostat humming quietly, the navigation in your car, or, the face recognition that unlocks your phone almost instantly. Artificial intelligence, well, it isn't some far-off idea anymore, is it? Woven right into our daily lives, almost invisible sometimes. But even though it's everywhere, for a lot of us, AI still kind of works behind this black box. It just does its thing, and it feels a bit like magic. We don't quite see how. And that's exactly why we're here today. This is the deep dive. Our whole mission is to cut through all that noise. We grab a pile of your sources, articles, research papers, maybe even your notes, and we pull out the really important stuff. Think of this as like your shortcut to getting properly informed. We try to pack it with surprising facts, maybe a little bit of humor, just enough to keep you hooked. And today, we're diving headfirst into the world of AI. It's evolving so fast, sometimes confusing, but always fascinating. We've got a really ambitious plan today, actually. It reflects all the amazing material you've given us. We're going to look at how physicists, believe it or not, are using tools from, like, the quantum world to try and demystify AI, to peek inside that black box. Then we'll switch gears and see how artists are reacting, not just reacting, but actually embracing AI as a creative partner. After that, we'll unpack the huge shifts AI is causing in IT departments everywhere, asking some pretty big questions about the future work there. And then finally, we're going to touch on something that honestly felt like science fiction just a little while ago. The first real glimpses of artificial superintelligence. So it's the conversation that stretches all the way from like the quantum level up to the future of humanity itself. Pretty big scope. So as we get started, the big question for you listening in is, how does AI really work? Beyond the apps we use every day. What are its actual impacts deep down across fields as different as art and, say, enterprise IT? Maybe the most important question, where is all this heading? Especially when we think about human understanding, human control, and even what creativity and intelligence really mean anymore.
Yeah, get ready to explore all of that with us. We're going to peel back the layers, look at the complex mechanics, the really big implications of AI, and we'll be guided by the latest insights from researchers and industry folks, all from the sources you provided. This should be, well, hopefully enlightening, definitely thought-provoking, might challenge some assumptions,
Yeah.
and maybe reveal some new possibilities along the way.
Okay, so let's start right there with this whole idea of the black box.
hmm
It's a phrase you hear all the time when people talk about AI, right? And it really gets at how it's everywhere, but still so mysterious. I mean, we interact with it constantly. Think about predictive text on your phone, or the algorithm figuring out what movie you want to watch next, or those self-driving features popping up in cars now. Facial recognition, too. These are just, normal everyday things now. But the tech behind them, still a huge puzzle for most people. And that feeling, that sense of mystery, that's exactly what Kevin Zhang finds problematic. He's a physicist, an assistant professor at the University of Utah, and he really nails it, describing machine learning as this classic black box. He says, and this is a direct quote from the source material, you input a lot of data, and at some point it reasons and speaks and makes decisions like humans do. Quote. It feels like magic because we don't really know how it works.
Right, the magic part.
Exactly. And he argues that feeling of magic, well, it's just not good enough anymore. Why? Because, as he puts it, AI is now across many critical sectors of society. So we have to understand what our machine learning models are really doing, why something works or why something doesn't work. This isn't just about, fixing bugs or academic interests. It's become absolutely essential for society. We need to deploy this stuff responsibly.
That's such a critical point, and it really underlines the huge difference between, say, traditional computer programming and what we call machine learning. With traditional programming, the human programmer spells everything out, every single step. Detailed instructions for every task. Imagine writing software for a CT scanner, right? The programmer has to think of, well, countless scenarios and write specific rules. If you see X, do this. If Y, do that. It's all very clear, rule-based, human-defined. Machine learning, though, it's a whole different ballgame. Instead of rules, you feed it just tons and tons of data. Could be text, numbers, images, medical scans, whatever. And the model, it basically trains itself. It figures out patterns, learns relationships, makes predictions, all on its own. Now, sure, humans can still fiddle with it. They can tweak the parameters to get more accurate results, guide the learning a bit. But here's the catch. Here's the black box issue. They're often doing that without knowing how the model uses the data input to deliver the output.
Right. Just tweaking until it looks better.
Exactly. It's basically sophisticated trial and error. And that's not just inefficient, it's incredibly expensive when you're talking about these massive AI models. Costs millions in computing power and time. And that's where someone like Zhang, with his background, becomes so valuable. He's a theoretical particle physicist. His day job traditionally is explaining the universe by understanding the tiniest bits of matter, right? The fundamental components. He's used to digging deep, finding the basic laws behind complex stuff. So now he's taking those same analytical tools designed for like cosmic mysteries, and he's applying them to these hugely complex machine learning models. His goal, basically, is to get a real foundational understanding of how AI behaves, to move beyond just guessing and checking beyond that costly trial and error that's so common right now.
And when you think about the scale involved, that trial and error thing isn't just inefficient, it's almost impossible financially. Machine learning, especially the really big models, uses a ton of energy. It's just wildly expensive.
Yeah.
The sources point at this common industry practice, right? To save money, companies often train models on smaller data sets first.
Yeah, test the waters.
Exactly.
Yeah.
And only if that looks promising do they scale them up to real-world scenarios with much larger volumes of data. In that scaling up part, that's where the costs just explode. So Zhang's asking this absolutely crucial question. It's got huge economic implications, performance prediction implications. He asks, we want to be able to predict how much better the model will do at scale. If you double the size of the model or double the size of the data set, does the model become 2 times better, 4 times better?
Yeah, how does performance scale? It's the million-dollar question, or maybe billion-dollar question.
Right. It's not just idle curiosity. It's about knowing beforehand how an AI will perform and what it will cost as it grows before you pour, potentially hundreds of millions of dollars and insane amounts of computing power into training it. It's about bringing some scientific rigor, some predictability to what's often been a bit of a guessing game.
And this is exactly where Zhang's physics background leads to this brilliant application. So inside that black box, especially in deep learning, you've got what's called a neural network. You can picture it like a massive tangled web of really simple math operations, but when you connect them all up in this complex way, they can learn to approximate incredibly complicated things, learn patterns from data. But optimizing that network, getting it to learn well, that's traditionally involved all that expensive trial and error fine-tuning. So Zhang looks back into physics history and pulls out this amazing tool, Richard Feynman's Feynman diagrams.
Feynman diagrams from particle physics. How does that even connect?
It's wild, right? Think about trying to calculate every possible way tiny particles like electrons interact in the quantum world. It's impossibly complex, like infinite calculations. Feynman, back in the 40s, came up with these simple diagrams, almost like little pictures where every line and junction represents a particle or an interaction. Suddenly, these hopelessly complicated calculations became manageable. You could see them, track them. It made the complex graspable. And Zhang has basically done the same thing, but for AI neural networks. His research, published in 2022, shows how he used these diagram techniques to figure out the scaling laws of a particular AI model. Those laws predict how well it performs as you make it bigger. His method let him solve the model's behavior beyond that limit where older methods failed. He got new and more precise scaling laws.
What the hell? So he can actually predict performance better now.
Exactly, with much more scientific precision. It's incredible. Tools built for understanding the universe's basic blocks are now unlocking the secrets of AI. It's a huge step away from trial and error towards a real theoretical grasp of how these things work, and it really shows the vital role physicists can play here, working alongside engineers and computer scientists to build AI responsibly.
That is really powerful. So if physicists can genuinely predict AI behavior like this, what does that mean for the industry? Does it speed things up or make them more cautious?
I think it makes development much more deliberate and efficient, actually. Instead of just scaling up blindly and hoping for the best, spending fortunes on computation, companies could use these kinds of scaling laws to figure out the optimal size, the right amount of data for the performance they need. It makes the whole process more predictable, saves resources, and should lead to faster, more reliable AI deployment in the long run. Less guesswork, more science.
And Zhang doesn't stop there. He takes this understanding and offers a warning. But it's not the usual sci-fi thing, robots taking over.
No killer robots.
Not exactly. He presents something maybe more subtle, but just as profound a danger. He says it's not about robots colonizing and enslaving humans, okay? It's that we humans build machines that we are struggling to understand, and our lives are already deeply influenced by these machines. And he gives a really concrete example that probably hits home for a lot of us. He mentions YouTube algorithms that recommend videos that suck each person into their own little corners and influence our behavior.
Ah, the recommendation rabbit hole.
Precisely. So that black box problem is right there in your feed. It's personal. How much of what you see online, the news you read, the opinions you encounter, how much is shaped by systems we just don't fully get? It's a really critical question for all of us living in this algorithm-heavy world. It's about influence. Subtle but pervasive, not necessarily overt control.
Yeah, and that pervasive influence, it's not just happening in the lab or on YouTube. It's already making massive waves across entire industries. It's reshaping global economics, even geopolitics. You just have to look at the components that power AI, right? Those advanced chips. They're now front and center in international trade deals, national security strategies. There was this huge headline recently, really unprecedented. Yeah. NVIDIA and AMD, the big chip giants, they agreed to pay 15% of China chip export revenues to U.S. just to get licenses to keep selling certain high-end chips to China.
Wow, 15%, that's significant.
It's huge, and it's not just about the money for the U.S. It raises some fascinating questions, doesn't it? Are we seeing a new kind of economic diplomacy where access to AI tech becomes this major bargaining chip, creating like AI dependencies?
So less about outright bans, more about controlled access and revenue sharing.
Exactly. It's a shift. What does that mean for the future? Who gets the best AI? Who leads innovation? It really just highlights how deeply AI is now tangled up with national power and global competition.
And while all that high-stakes stuff is happening globally, we're also seeing some, frankly, pretty wild impacts closer to home. Especially in media. Have you heard about this AI slop thing taking over YouTube?
Vaguely, it sounds messy.
Oh, it is. It's basically mass-produced, often really bizarre AI-generated videos, sometimes surreal, sometimes just nonsensical, talking animals that look almost real but not quite, weird kids content just churned out constantly, and the scale is just staggering. The sources say that nearly 1 in 10 of the fastest-growing channels globally consist of mass-produced, surreal, AI-generated videos.
1 in 10? That's a lot more than I would have guessed.
It's not just a tiny fringe thing anymore. It's a big chunk of what's getting views. So what does that mean? For real creators trying to get noticed, for us trying to tell what's quality, what's just noise, does it change what creativity even means online? Is it a revolution, letting anyone create?
Yeah.
Or just digital landfill?
It feels like it might devalue human effort, potentially.
Well, the sources suggest platforms are already struggling with quality control because of it. And maybe, just maybe, it makes us value actual human-made stuff even more. Looking for that authenticity.
That need for authenticity, for discerning what's real, that leads us straight into some really serious ethical territory, especially in critical areas like healthcare. There's some exclusive research out of the London School of Economics, the LSE, really concerning findings. They found that AI tools being used right now by English councils are actually downplaying women's health issues.
Downplaying them? How?
The AI summarizes patient case notes, but it seems to be systematically biased. It creates a risk of gender bias in care decisions made based on AI summaries.
It's incredibly serious, real-world impact on people's health.
Exactly. And often the root cause is the data that AI was trained on. If historical health data already underrepresents women's issues or certain groups, the AI learns those biases. It doesn't just reflect them, it can amplify them.
And embed them right into the decision-making process.
Right. So if we're still struggling with the black box, not fully knowing how the AI reaches conclusions, how do we even find these hidden biases? How do we fix them, especially when people's health is on the line? It just screams for more careful development, rigorous testing, transparency. We need ethical guardrails.
Absolutely. Fairness in AI is paramount, even as it opens new doors. But okay, while we grapple with those concerns, AI is also simultaneously sparking creativity in unexpected ways, particularly in the arts. You know, talk about AI and art, and you get really strong opinions, don't you?
Oh, yeah. Polarized is the word.
Some people immediately think, okay, robots are taking over, art is dead. Like, it's the end of human creativity. But then others see it completely differently. They see AI as this amazing new tool, something that enhances creativity, opens up new possibilities. Rebecca Zhu, she's a professor of computer art and animation at Syracuse University. She's firmly in that second camp. She says straight out, I'm on the side that AI is having a positive impact. For her, it's not a threat. It's just another tool we can use with our creative practices. Simple as that. And she makes this really interesting comparison, drawing a parallel to another technology that totally freaked out the art world back in the day.
Ah, the camera analogy.
Exactly, the invention of the camera.
Yeah, that comparison is so helpful, gives real perspective. When photography first appeared, it absolutely terrified many artists, especially painters. Before cameras, painting was how you captured reality, right? Portraits, landscapes, historical scenes. So painters, particularly the realists, thought, well, that's it. The camera does it instantly. Our skills are pointless now.
They thought it would make their work meaningless.
Totally. But what actually happened, the camera didn't kill painting at all. It actually freed painting from having to be purely representational. It pushed artists towards impressionism, cubism, abstraction, new ways of seeing. And of course, it created a whole new art form. Photography itself, it expanded creativity, it didn't replace it. And Yu's core philosophy really gets at this. She emphasizes art is always about self-expression. Whether you use a camera, a paintbrush, clay, or computer software and AI, those are the media and different means for creating art. The content and how you communicate through your art is the most important thing.
So it's not about the tool, it's about the artist's voice, their intention.
Precisely. The medium changes, the tools evolve, but the human drive to express something unique, that remains constant. It puts the focus back on the artist, not the algorithm.
That's such a refreshing way to look at it. Beyond fear towards partnership. And she puts this into practice too. She explains how she actually teaches her students to use AI, especially in what she calls the pre-production phase. So using AI for brainstorming, generating ideas and inspiration, helping them quickly mock up concepts, develop story ideas, try out different character designs, explore visual styles.
Like a super fast concept artist assistant.
Exactly. It lets them experiment rapidly before they commit to the heavy lifting of actual production. Speeds things up, broadens possibilities. And she also says AI can be a very good training tool for learning technical skills. Like, students can use it to quickly see the difference between a long shot, medium shot, close-up in filmmaking, helps them grasp the basics visually. But, and this is a big but, she hammers this home with her students. They still absolutely have to produce your own original work instead of using something generated by AI.
So it's an aid, not a replacement for their own creativity.
Right. It's a collaborator, an idea generator, but the final piece needs that human originality, that personal stamp. And maybe most importantly, she points out, not everybody needs to use AI. Traditional arts, painting, ceramics, sculpture, they retain their own values. Why? Because they're handmade. They show the human touch, the effort, the intention. She argues, quite powerfully, that the human touches and the lived human experiences that shape the art form are irreplaceable. In fact, she thinks that AI becoming so common might actually make us value traditional artwork even more.
Interesting, because it highlights what's uniquely human.
Yeah, exactly. It throws that human element into sharper relief. It's a choice for the artist, and maybe a deeper appreciation from the audience.
And that really brings us back to critical thinking, doesn't it? Recognizing that real creativity stems from human intent, from lived experience, from the desire to express something. The tool is secondary. AI can be an amazing enabler, a collaborator, even a way to prototype ideas incredibly quickly. But the vision, the core idea, the why behind the art, that's still human. It forces us to think harder about what creativity is when a machine can generate so much. Where does that human spark truly matter? It seems AI changes how we create, but maybe not the fundamental human need to create.
Okay, shifting gears again. If you're listening and you work in IT, maybe you're a CIO or involved in tech strategy, this next bit is probably keeping you up at night.
Yeah.
There's this big existential question hanging over the field right now. One of our sources, a CIO article, just laid it out there. Is AI the end of IT as we know it?
Wow, pulling no punches.
None at all. They even bring up that REM song, that's the end of the world as we know it, to capture the feeling, this sense of information overload and anxiety over cultural and political chaos that a lot of IT leaders are apparently feeling right now. And it's not just hype. The sources show that many CIOs are seriously thinking about how AI is going to completely change IT's purpose, its whole way of working. The reactions are all over the map. Some people imagine AI agents just running IT departments autonomously.
No humans needed.
Yeah. While others are total doomsayers, warning about ungoverned and rogue AI agents causing chaos and disaster. It's a really pivotal moment for IT. Transformative, maybe a bit terrifying for some. The decisions being made right now are huge.
And that uncertainty naturally makes people wonder about the role of the CIO themselves. Is that role safe? Martin Davis, he's a CIO, managing partner at Dental Associates. He asks this really provocative question. He says, if you're a CEO and you're seeing all this AI generating code, you've got to be thinking to yourself, why do I need a CIO anymore?
Ouch. That's direct.
Yeah, it is. But then he immediately answers it himself. He looks back at history, at things like outsourcing cycles, and he says, we've seen this in the past, and we find that we do need IT, but the role of IT does change and evolve. So his view is it's not about IT disappearing, it's about IT transforming, adapting. And Joanne Friedman, CEO of Connected Minds, she offers an even more positive take, maybe even transformative. She sees AI not as a threat, but as the catalyst for IT to finally become what it always should have been, to go way beyond having a seat at the table and become a business unit strategically important to the organization.
So moving from a cost center to a core value driver.
Exactly. She even suggests AI could push the CIO towards a CEO role in some cases. That's how central she thinks AI could make IT. And this isn't happening in a vacuum. It's part of a longer trend. Think about cloud computing, low-code platforms, DevOps. Those things already helped IT teams move upstack, away from just managing servers and wires towards higher-level stuff. AI is set to accelerate that massively, freeing up IT folks from routine tasks to focus on the big picture, on where AI can deliver business value rather than just building and maintaining the underlying tech.
So more focus on strategy, customer experience, using AI from profit.
Precisely. But there's a catch. CIOs are also going to face significant pressure from boards to reduce IT spend, automate more, use service providers, cut down on old systems, at technical debt. So it's a double pressure. Be more strategic and be more efficient.
Okay, so if IT is moving upstack, what happens to the people actually writing the code? Is AI the end of programmers? I mean, some of the numbers coming out of big tech companies are pretty jaw-dropping. Boris Cherny at Anthropic says their AI, Claude, writes nearly 80% of Anthropic's code. Now, presumably with a lot of human oversight, but still, 80%.
That's a huge number.
And Satya Nadella at Microsoft estimates AI writes maybe 20–30% of the company's code. These aren't small figures. It suggests a real shift in how software gets made. And if you need more convincing, look at the developers themselves. The 2025 Stack Overflow Developer Survey, a big deal in the dev world, found that 84% of respondents are using or planning to use AI tools in their development process.
84%. That's almost everyone.
It's massive adoption, incredibly fast, but like always, it's complicated. Door's report says 75% of developers reported positive impacts on productivity. That's great, but 39% of developers trust the quality of Gen AI output only a little or not at all.
The trust issue. Productive, but maybe not reliable.
There seems to be a gap there. Although another board, Quoto's State of AI Code Quality, found 70% of development teams claiming improved productivity also report improved code quality. So the picture's a bit mixed, lots of optimism, some healthy skepticism, but the trend is undeniable. AI is changing coding.
Which leads to a more, let's say, balanced view of what's happening. Joe Puglisi from 10 Nuco offers this really useful historical perspective. He compares AI code generation to past shifts, like when programmers stopped writing low-level assembly code, which is super detailed, and started using compilers and higher-level languages, which handle a lot of that complexity automatically. He argues this is just a natural progression of capabilities and not the end of programming.
So not replacing programmers, but changing the nature of programming.
Exactly. It's the next step in the evolution of software development tools. Programmers are still needed, but what they do will change. And Dominic Anger from Storyblock builds on that. He sees AI supercharging current practices like Agile and DevOps. He imagines daily team meetings, stand-ups becoming data-driven thanks to AI insights. He sees the automated software pipelines, CI/CD, becoming self-optimizing, and quality assurance, QA, leaning on AI for test creation and coverage, speeding everything up.
So developers spend less time writing code line by line.
Right. He says developers will shift from coding to curating, reviewing, refining, integrating AI-generated code. And get this, he sees business users being able to just describe ideas in natural language, and AI will build functional prototypes instantly.
Whoa! Democratizing development.
Totally. More people involved, but it also means IT has to focus even more on oversight, scalability, and compliance. Less hands-on building, more managing the overall intelligence system. So if that's software development, what about IT operations? The people keeping the lights on, is it true? Will data centers go dark, just run themselves? Will IT support become completely self-service and fully automated? Will our devices just fix themselves?
That's the big question, isn't it?
Well, Nikhil Mungal from Cripple suggests the focus will shift. Less managing physical laptops and servers, more ensuring virtual agents running in the cloud stay compliant and secure. It's a different kind of management, the traditional help desk. It probably moves from just fixing problems to providing oversight on how AI agents respond to them. Humans handle the tricky stuff. And Jimmy Mesta at RAD Security talks about AI systems that can auto-triage alerts, generate risk assessments, and suggest or implement remediations directly.
Self-healing infrastructure.
Pretty much, especially in the cloud. systems that fix themselves before you even know they're broken. But let's be realistic, there are big hurdles. Legacy systems, integration gaps, undocumented workflows, all that technical debt companies have built up.
Yeah, the messy reality.
Right, it's not a clean slate. And Jonathan Zaleski from Happy Fun Corp points out IT's role expands. It has to include things like AI governance, ethical oversight, and strategic orchestration, because applications are becoming these intelligent, adaptive agents. Just managing systems isn't enough. You have to manage intelligence and security. He says security models will need rethinking entirely.
Because AI agents interact differently, create new risks.
Exactly. Remember when cloud computing came along? People thought it might end IT ops. Instead, it just increased the scope, scale, security, and risks. AI will likely do the same. More complexity, needing AI to manage the AI, and creating new, higher-level IT jobs. Full automation seems unlikely anytime soon. Augmentation is more probable.
Okay, so definitely not the end of IT, but a massive reshaping, huge adaptation needed. And this change spills out beyond IT itself into the whole digital workforce. Which brings up this new headache, shadow AI. We saw something similar with low-code tools and citizen data scientists, right?
Yeah, where business users started doing tasks that used to belong only to IT.
Exactly. And what did IT have to do? They had to build supportive functions. Centers of excellence for governance, quality control, making sure things integrated properly. Now, AI is taking that trend and putting it on steroids, pushing powerful tech capabilities even further out, shifting them left into business functions. Liev Caspi from Legit Security puts it really well. Low-code will evolve into AI systems that generate apps from prompts, replacing drag and drop with iterative prompt review cycles.
So anyone can build apps just by describing them.
Potentially, yeah. Which is amazing for innovation. Marcus Torres at QuickBase says generative AI is redefining virtually every function by shifting the role of the workforce from creation to curation, and this includes IT. Everyone becomes a curator of AI-generated output. But here's the danger. All this power in the hands of non-IT folks leads to new complexity of custom, unstandardized solutions built outside governance models. And that is the shadow AI agent problem, as Rishi Bhargava from Descope calls it.
People building their own AI tools under the radar.
Exactly. IT suddenly has these new IT and security responsibilities to ensure AI adoption doesn't come at the expense of an increased risk surface and compliance challenges. Imagine employees automating sensitive processes with AI tools IT doesn't even know exist. Huge potential for data leaks, security holes.
So IT's core job managing complexity, taming chaos just got way harder.
Intensified, for sure. They need new ways to govern and oversee all this distributed AI power. So, summing up the future of IT, what's the final verdict? The sources really show two sides of the coin. It's a glass half empty or glass half full situation.
Half empty.
Yeah, it points to a massive shift that will eliminate many traditional IT jobs, especially the repetitive ones. But the half full view, it shows how IT must step up, seize new opportunities, take on bigger responsibilities, become more strategic than ever.
So adapt or become irrelevant.
That's the message. CIOs need to prepare now, staff up new roles, AI change agents, Gen AI business analysts, workplace futurists. Fancy titles, but real needs. They have to completely rethink their digital transformation strategies for the Gen AI era. Put AI right at the center, because the warning is stark. CIOs who just keep doing things the old way, who manage based on pre-AI expectations, they might genuinely find that for them, it is the end of IT as they know it. Adaptation isn't optional. Okay, wow. As if demystifying the black box, seeing AI in art, and reshaping IT wasn't enough. We're now heading into territory that honestly felt like pure sci-fi until like 5 minutes ago. We're talking about the path to superintelligence, and the truly wild thing is, we're already seeing the first glimmers. There was this huge announcement from Mark Zuckerberg at Meta in a policy paper just published July 30th, 2025. He revealed that Meta researchers have begun to see glimpses of our AI systems improving themselves without human input.
Improving themselves without humans intervening.
That's what he said. Not just getting better at a task, but actually changing their own internal workings, apparently. He described it as slow for now, but undeniable. And here's the bombshell. He called it the first step towards achieving artificial superintelligence, or ASI.
ASI, that's a massive statement.
Huge. It suggests we're potentially on a path to creating intelligence that goes far beyond human abilities. It changes everything.
It really does. And it's maybe worth quickly defining what we mean by ASI. in the context of how researchers usually categorize AI. They typically talk about three levels, three strata of AI capability. First, there's narrow AI. That's basically where we are now. These AIs can do amazing things, extraordinary superhuman feats, but only in very specific areas, like predicting how proteins fold, incredible scientific achievement, but highly specialized. That AI can't suddenly write a novel or argue philosophy.
You're good at one thing.
Exactly. Lacks general smarts across different fields. The next step up is artificial general intelligence, AGI. This is kind of the dream for many in AI. AGI refers to models that can understand, learn, and adapt in much the same way as the human brain. So, an AI with human-like cognitive abilities, it could learn pretty much any intellectual task a human can, generalize, reason, be creative.
The kind of AI you see in movies, basically.
Pretty much, and that hypothetical moment we achieve AGI, that's often called the technological singularity, the point where tech growth might just spiral beyond our control, changing civilization forever. And then the final level, artificial superintelligence, ASI. This is what Zuckerberg was talking about. This is AI that has evolved to far exceed human potential, not just in one area, but across the board, cognitively. And here's the crucial part, linking back to Zuckerberg's point. ASIs could potentially improve themselves at an exponential rate, leading to an intelligence explosion.
The self-improvement thing, that's the key.
Exactly. An ASI wouldn't just be smarter than us. It could rapidly become vastly, maybe incomprehensibly smarter, improving itself faster than we could even track. That's the potential game changer. Now, while Zuckerberg's announcement from Meta is recent news, this idea of AI self-improvement, it's not entirely brand new. It's been seen before, even proven theoretically. There was a really important paper back in October 2024 from researchers at UC Santa Barbara. Their work was based on this concept called the Gödel machine.
The Gödel machine. Sounds intense.
It is. It's a theoretical concept, originally from Jürgen Schmidhuber. Imagine a machine that can actually rewrite its own programming to make itself better. But here's the incredibly clever part. It would only make a change if it could first produce a formal proof that the change would be beneficial.
A mathematical proof. So it has to prove the upgrade is good before doing it.
Precisely. It's not just random mutation, it's provably beneficial self-improvement based on logic. The UCSB team actually built an AI framework based on that concept called a Gödel agent. And in their experiments, this agent could access its own code, understand it, and access the code for potential improvements. And crucially, it could mathematically show that those improvements were beneficial before implementing them. The study found it consistently showed better performance in key areas than the human-designed agents to which it was compared.
Wow. So they actually demonstrated provable self-improvement.
Yes. It takes it from theory to a demonstrated reality. It provides a concrete example of the kind of self-modification that Zuckerberg is now seeing hints of at Meta's scale. It makes the whole ASI idea feel much less abstract.
Truly mind-bending stuff.
Yeah.
And despite the, potentially terrifying implications of superintelligence, Zuckerberg sounds pretty positive about it. He actually says he's extremely optimistic that superintelligence will help humanity accelerate our pace of progress, or leading to the discovery of new things that aren't imaginable today. He sees it unlocking massive breakthroughs in science, medicine, everything. He even talks about this vision of a new era of personal empowerment. He paints this picture where maybe you'll have your own personal superintelligence. An AI that helps you achieve your goals, create what you want to see in the world, experience any adventure, be a better friend, grow to become the person you aspire to be.
Like the ultimate personalized life coach, mentor, and assistant, all rolled into one.
Exactly. Helping you optimize, well, everything. And it's a really significant but. Coming directly from Meta's observations of this self-improvement, there's a very real policy change happening. Zuckerberg stated clearly that Meta would now be far more careful about which models the company chooses to release to the public under an open source framework.
So pulling back on open sourcing the most advanced stuff.
It sounds like it. It's a clear signal that they recognize the sheer power and maybe the risks of these rapidly evolving self-improving systems. Even if the intent is good, the potential for unforeseen consequences is just too high. It demands more caution, more control. It's a shift from their previous open approach.
And that tension is just fascinating, isn't it? On one hand, this almost limitless optimism about AI accelerating human progress, and on the other, this very clear, pragmatic acknowledgement that we need more caution, more control as these systems get smarter, especially if they start improving themselves. It's a really tricky balancing act, embracing the potential while trying to manage the risks. And seeing this policy shift from Meta, one of the biggest players, It really underlines that even the people building this technology understand the gravity of it and the responsibility they hold. Hashtag Shagheka outro.
Wow. We have covered a lot of ground today, haven't we? Started with physicists using Feynman diagrams, of all things, to peek inside AI's black box, trying to make its behavior predictable. Then we saw artists not fearing AI, but actually using it as a creative partner, a new tool. We unpacked the massive changes hitting the IT world, the shift to curation, the challenge of shadow AI. And then we ended up staring at the first real signs of self-improving AI, the dawn of potential superintelligence, and the cautious steps being taken by its creators. It's been quite the journey across the AI map.
It really has, and I think what comes through so clearly from all these different angles is that AI isn't just another piece of tech. It's not just a tool. It's this rapidly evolving, maybe even self-evolving force that's fundamentally changing how we think about intelligence itself, about creativity, about work, maybe even about what it means to be human. And this whole story, this journey of discovery, feels like it's really just getting started. And man, is it speeding up, unbelievably fast.
So as we finish up this deep dive, the big question we want to leave with you is, what does all this mean for you? For your life, your job, your future? As these AI systems get better at improving themselves, maybe faster than we can even keep up with, as the line between human creativity and machine generation keeps blurring, how do we make sure we're not just passive consumers of this technology? How do we stay active, informed participants in shaping where it goes? What kind of relationship do you actually want with that future personal superintelligence Zuckerberg talked about? And what responsibilities come with that? What ethical lines do we need to draw? Because this future isn't just something that happens to us, it's being built right now. By this tech, yes, but also by the choices we all make about it. Lots to think about. Thank you so much for joining us on this deep dive into the incredibly complex world of AI. Keep exploring, keep asking questions, and definitely keep learning.